the maximum distance for 200 amp underground residential service is 100 feet, which is equivalent to 30.5 meters. The wire size required depends on whether you are using copper or aluminum conductors. For copper wire, a size of 4/0 AWG, which is equivalent to 212 kcmil, is needed. For aluminum wire, a size of 4/0 AWG, which is equivalent to 240 kcmil, is required. These recommendations are based on the National Electrical Code, specifically the 2020 edition. It's important to note that local codes and regulations may differ from the national code, so it's always recommended to consult with a licensed electrician in the specific area to ensure compliance with all applicable requirements. The selection of the correct wire size and the determination of the maximum allowable distance are crucial aspects of electrical installations. Several factors influence these decisions, including voltage drop, current carrying capacity, and the allowable heating of the conductors. Firstly, voltage drop refers to the reduction in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause appliances and equipment to operate inefficiently or even malfunction. The NEC sets limits on the allowable voltage drop for branch circuits and feeders, and these limits must be considered when selecting wire sizes and determining maximum distances. Secondly, current carrying capacity, also known as ampacity, is the maximum amount of current that a conductor can safely carry without exceeding its temperature rating. The ampacity of a conductor depends on its size, material, insulation type, and the ambient temperature in which it is installed. The NEC provides tables that list the ampacities of various conductors under different conditions. Thirdly, the allowable heating of the conductors is another important factor to consider. When current flows through a conductor, it generates heat due to the conductor's resistance. Excessive heat can damage the insulation of the conductor, leading to insulation failure and potential hazards. The NEC sets limits on the maximum allowable temperature of conductors, and these limits must be considered when selecting wire sizes and determining maximum distances. The distance is measured from the point of connection to the meter to the point of connection at the building. This entire run must be taken into account when calculating voltage drop and ensuring that the wire size is adequate for the load. Proper installation techniques and materials are crucial to ensure the safety and reliability of the electrical system. This includes using the correct type of connectors, properly terminating the conductors, and protecting the conductors from physical damage. It also includes ensuring that the conductors are properly grounded and bonded to prevent electrical shock hazards. In addition to the factors mentioned above, it's also important to consider the type of load that will be served by the electrical system. For example, if the load includes motors or other inductive devices, it may be necessary to increase the wire size to account for the inrush current that these devices draw when they start up. Inrush current can cause a significant voltage drop, which can affect the performance of other equipment on the same circuit. Furthermore, the type of raceway or conduit used to enclose the conductors can also affect the ampacity of the conductors. When conductors are installed in conduit, they are typically derated to account for the fact that the conduit restricts the flow of heat away from the conductors. The NEC provides tables that list the derating factors for different types of conduit and different numbers of conductors in the conduit. When selecting wire sizes and determining maximum distances, it's important to use the correct derating factors to ensure that the conductors are not overloaded. The NEC also specifies the requirements for grounding and bonding of electrical systems. Grounding is the process of connecting the electrical system to the earth, which provides a low impedance path for fault current to flow back to the source. Bonding is the process of connecting all of the metal parts of the electrical system together, which helps to equalize the voltage potential and prevent electrical shock hazards. Proper grounding and bonding are essential for the safety of the electrical system. In addition to the NEC, there may be other codes and standards that apply to electrical installations. For example, some states and municipalities have their own electrical codes that are based on the NEC but may have additional requirements. It's important to be familiar with all of the codes and standards that apply to the specific electrical installation. When working on electrical systems, it's important to always follow safe work practices. This includes energizing the circuit before working on it, using appropriate personal protective equipment, and following lockout/tagout procedures. Electrical work can be dangerous, and it's important to take all necessary precautions to prevent electrical shock and other hazards. Firstly, always verify that the power is off before beginning any electrical work. Use a voltage tester to confirm that the circuit is energized. Secondly, wear appropriate personal protective equipment, such as safety glasses, gloves, and insulated tools. Thirdly, follow lockout/tagout procedures to prevent the circuit from being accidentally energized while you are working on it. This involves placing a lock and tag on the circuit breaker or disconnect switch to indicate that the circuit is being worked on. The wire size requirements are based on certain assumptions about the installation conditions. For example, the NEC ampacity tables assume that the conductors are installed in a raceway or cable with no more than 3 current-carrying conductors. If there are more than 3 current-carrying conductors in a raceway or cable, the ampacity of the conductors must be derated. Similarly, the NEC voltage drop calculations assume that the conductors are installed at a certain temperature. If the conductors are installed in a hotter environment, the voltage drop will be greater. It is important to consider these factors when selecting wire sizes and determining maximum distances. The National Electrical Code provides guidelines for calculating voltage drop in electrical circuits. These calculations help determine the appropriate wire size to ensure that voltage drop remains within acceptable limits, typically 3% for branch circuits and 5% for feeders. Factors such as circuit length, load current, and conductor resistance are taken into account in these calculations. When using aluminum conductors, it is important to use connectors that are specifically designed for use with aluminum. Aluminum conductors are more susceptible to corrosion than copper conductors, and improper connections can lead to loose connections and overheating. Connectors that are designed for use with aluminum are typically made of aluminum or tin-plated copper and are designed to provide a gas-tight connection. Also, antioxidant compound is usually recommended. It is also important to follow the manufacturer's instructions when installing connectors. The instructions will provide information on the proper torque to use when tightening the connector screws. Over-tightening the screws can damage the connector, while under-tightening the screws can lead to a loose connection. The type of insulation used on the conductors can also affect the ampacity of the conductors. Different types of insulation have different temperature ratings. The higher the temperature rating, the more current the conductor can carry. The NEC provides tables that list the ampacities of conductors with different types of insulation. When selecting conductors, it is important to choose conductors with an insulation type that is appropriate for the application. The NEC also specifies the requirements for the installation of underground wiring. Underground wiring must be buried at a certain depth to protect it from physical damage. The depth of burial depends on the type of wiring and the location of the wiring. For example, direct burial cable must be buried deeper than wiring that is installed in conduit. The NEC also specifies the requirements for the protection of underground wiring from corrosion. Underground wiring must be protected from corrosion by being installed in a corrosion-resistant conduit or by being coated with a corrosion-resistant material. The selection of appropriate overcurrent protection is crucial for safeguarding electrical circuits and equipment. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of electricity in the event of an overload or short circuit, thereby preventing damage to wiring and equipment, as well as reducing the risk of electrical fires. The size and type of overcurrent protection device must be carefully selected based on the ampacity of the circuit conductors and the characteristics of the connected load. The goal is to provide adequate protection without causing nuisance tripping under normal operating conditions.